In today's class onwards, students, we start physics related lessons. In very beginning, we need to take about heat. So let us introduce heat ourselves. So what is heat? There is a common definition used by everyone. Heat is a form of energy. But remember, along with the heat, light, sound, electricity, magnetism, these are all also considered as energy. So unlike this, the heat is a form of energy, but the purpose for what it exists is not like the other sources. See here, each and every energy source has their own purpose. So what's the purpose of heat? To sense coldness or hotness. The purpose of sensing, the purpose of heat is the energy which is used to sense coldness or hotness. For this, we are using heat energy. Similarly, light senses vision, sound senses hearing, and this kind of different abilities are there. Okay, since the lesson is heat, we discuss about it also. Okay, so what's the importance of heat in our daily life? See, when you touch any object, we definitely feel coldness or hotness. That feeling of coldness or hotness is existence of heat. Okay, how will be the heat? Means in what form? How can the transfer takes place? See, these are all explained from the laws of calorimetry. We are going to discuss in the further topics. Okay, how do we measure measurement of heat? See, heat is measured in joules, since it is also energy. So heat SI unit is energy. And what about CGS unit? Calorie. Calorie is the CGS unit of energy. These are the units. And the device, heat can be measured using a device, calorimeter. And we have a formula also to measure heat is Q is equal to ms delta T. In some books it will be Q is equal to mc delta T, where Q is called heat, M is called mass, S or C is called specific heat capacity, and delta T is change in temperature. Here we need to know about temperature. Many people feel that heat and temperature are same words, but wrong. Temperature is a different word. Let us see the definition. As heat is a form of energy where we feel a coldness or a hotness, but the temperature is the degree of coldness or hotness. So whether the object is a cold body or a hot body, how much coldness it has, how much hotness it has, the rate that what we feel is called temperature. So temperature, its a measurement takes place using thermometer. It's measured using thermometer, and SI unit to measure temperature is Kelvin. This is called absolute temperature. We discuss next about this absolute temperature, and CGS unit is Celsius. CGS unit is Celsius. So this is how we are going to express temperature. Okay, and actual topic is measurement of temperature. Before that, we just take how heat, we have a small explanation how heat is transferred. See, transfer of heat is depending upon the three conditions. They are called laws of calorimetry or principle of method of mixtures. According to it, the first rule is explained: heat transfers from hot body to cold body. So heat always transfer from hot substance to cold substance. So if a hot coffee and is poured into cool water, what's going to happen is the hotness present in the coffee is transferred to water. So if one more example for oil, hot oil. Into hot oil, when water is poured, so what we are going to see is the hotness present in the oil will be transferred to water. The second rule is when heat transfers, hot body loses its hotness, cold body gains heat. Hot body loses its hotness and cold body gains heat. How long this happen? Until both temperatures are equal. Means what? hot body temperature and cold body temperature. Both bodies temperature when gets equal, the transfer immediately stops. Until then, the heat transfer from hot body to cold body continues, and when the temperatures are equal, this situation is called thermal equilibrium. The situation where temperature of hot body and cold body equal, that situation is called thermal equilibrium. And the third statement is heat lost by hot body is equal to heat gained by cold body. Heat lost by hot body, that means when hot body loses its heat, how much the quantity is equal to the heat gained by the cold body, how much it gains. These are the three laws. But one more thing, condition is there to we need to remember. The average kinetic energy of particles, the average kinetic energy of particles is directly proportional to its absolute temperature. Means what? Kinetic energy is proportional to temperature. That means when the temperature increases, the particles are going to gain more kinetic energy. This can be explained by a small activity. A container, water present in it. And at the bottom, we are going to have a spirit lamp. So what are we going to see here? Using this spirit lamp, we slowly start heating the water present in it. When the heating process begins slowly, you can see formation of water droplets, and slowly these start moving towards surface. When the heating process increases continuously, the velocity or the rate of bubbles move towards the surface increases. Why is the particles motion is caused by their kinetic energy. And why the speed increase means by heating the temperature of water increases. When the water's temperature increases, the rate with what the particles move to the surface also increase. This is kinetic energy and temperature relation can be proved with a small observation. Okay. Similarly, we can also prove thermal equilibrium. How is? Again we do one more activity. This time a container we take, and very less part of it is powered by water, and with the help of a stand at one side, we are going to fix a thermometer which measures the temperature of water, let it be T1. So if the water is cold, let us assume the water is cold. The cold water will have a lower temperature, so T1 is less. And then we drop oil and is hot. This is water. Oil which is hot into the same container, and again we are going to fix one more thermometer into it which measures the temperature of oil. Why is the bulb of initial thermometer is kept in water. The second thermometer bulb is kept in oil, so it measures the temperature of oil is T2, and since it is hot, it will have a maximum temperature. So when the two are mixed here, that means in the container of water, when hot oil is added, after some time we can observe that slowly the temperature T1 starts increase. The temperature T1 slowly starts increase and the temperature T2 falls. How long this happens? Until T1 is getting equal to T2. So this rise, this fall, both will continue until T1 temperature is equal to T2. That means both will become equal. That equal temperature T can be called as a thermal equilibrium. This is called as a thermal equilibrium. Okay. So you can also theoretically can calculate this thermal equilibrium. How can it be is, let us know that from the laws of calorimetry, heat lost is equal to heat gained. From the laws of calorimetry, we know heat lost by a body is equal to heat gained. You see, who is losing heat here? The oil, because it was taken hot, and at thermal equilibrium its temperature fall. When temperature falls down, the temperature of oil decreases. That means oil loses the heat and water gains the heat. If we can measure the heat lost by oil and heat gained by water, then both are equal according to laws of calorimetry, and that gives thermal equilibrium. Let us measure. Let us take the hot oil's temperature M1 and water's temperature, mass of oil M1, mass of water M2, specific heat of oil S1, specific heat of water S2. To measure heat, we have a formula. Q is equal to ms delta T. Q is equal to ms delta T. First we calculate lost heat. Lost heat can be, it is in oil. So oil measurements, we need to substitute what? Mass, specific heat, change in temperature. See, the temperature was here initially T2. After reducing, it became thermal equilibrium. That means in this thermometer final temperature is T. in this situation also, actually the temperature was T1 very minimum. After increasing, the increased temperature is once again capital T only, because T1 is equal to T2 at thermal equilibrium. So when heat is lost in the oil, that will be measured. Mass is M1, oil's mass, and specific heat is S1. And the temperature, this is where we need to be careful, because the temperature always I choose maximum minus minimum. Here maximum temperature T2, minimum temperature is none other than thermal equilibrium, so it is T2 minus T, change in temperature. Then heat gain in the water situation, we need to observe water's mass M2, specific heat S2. Let us substitute M2, specific heat is S2. Now important thing is change in temperature. See, initially the temperature was T1 is the minimum. Now at thermal equilibrium T is a maximum. So change in temperature is maximum temperature T minus minimum temperature T1. Let us take the calculations. So by multiplying M1 S1 we have changed the terms. Okay, let us change the temperatures. T2 as a T1, T1 as a T2. For our convenience, I have changed. Oil's temperature, let us assume T1, and water's temperature T2. Then this is T1 and this is T2. Now M1 S1 T1 minus M1 S1 T is equal to this product M2 S2 T minus M2 S2 T2. Exchanging the negative terms, M1 S1 T1 is a positive term, and RHS negative term minus M2 S2 T2 bringing into LH, it will be plus M2 S2 T2, and LHS negative term minus M1 S1 T transposing the side, plus M1 S1 T plus there already a positive term M2 S2 T. And here exchanging the terms, and from RHS commoning capital T. Commoning capital T, here we have M1 S1 plus M2 S2, and LHS writing RHS M1 S1 T1 plus M2 S2 T2. Then finally T is equal to M1 S1 T1 plus M2 S2 T2 by M1 S1 plus M2 S2. This is the equation to find a thermal equilibrium. If we want to find a thermal equilibrium when heat transfer takes place between same materials, for same materials specific heat S1 is equal to S2. See, when the materials are same, they are going to have same specific heat. About the specific heat in next class we are going to learn. So at this situation, T is equal to M1 ST1 plus M2 ST2, because the specific heats are same. In denominator also M1S plus M2S. Now from this numerator S gets common, M1 T1 plus M2 T2. Denominator again S gets common, M1 plus M2. S will be cancelled each other, then T is equal to M1 T1 plus M2 T2 by M1 plus M2. So thermal equilibrium for same materials. This is about heat and thermal equilibrium. There are still some more topics to discuss regarding this introductory part. It is all still introduction, and this is today's topic. And in next class, I am going to explain what is the specific heat and advantages, and also I am going to explain the temperature and temperature measuring scales. Let's see in the next class. Okay.